Hello friends, welcome to my channel, and today I am here after a long time on some of the Python fundamentals, and we start with algorithms today. Yeah, algorithms, the world of algorithms, which have multiple uses in our real day life. Many enterprise applications are based on algorithms of different kind, hues and shades. You might have heard of names like insertion sort, bubble sort, binary trees, binary search, and lots more. You also might have heard of trees, graphs. So we would cover them one by one. Today, I would be taking you through a very widely used algorithm, and it has good applications in higher classes in schools also. The computer science or students or the initial computer engineering students also learn this, and it is taught in different programming languages. Here my approach would be to first take you through the pseudocode, followed by the actual running code. I would be writing in Python. Of course, one can implement in other languages like Java, or if someone is fond of using C++ there. And even I have seen some examples where JavaScript can be used. So first, let's have the pseudocode. Uh, Here in the comments you can see I've written is binary search, and I would be using recursion. Binary search can be performed without recursion, like iterative approach. But here, iterative, you can see the normal approach where we could be dividing an array into based on a partition, and then we would increment or decrement accordingly. So, as an input, we have a sorted array. Always remember, that binary, sorry, search would need a sorted array input. So this is a key requirement for binary search. Then we have the start index. Normally it would be 0. It's the first element, and then the end index, normally the last element. But of course we can, if we want, we can go for something like the combination. If there are 8 elements and the end index is 7, then we can do search within 0 to 5, or maybe 1 to 4 or 1 to 5, whatever. Those are the rare cases. Normally we would be scanning the whole array. Then search underscore element, which is the element we search. So we define the function, we pass as inputs the array, then the starting index, end index, and the element we search. The base case would be where the start index exceeds end index, and then it would mean practically that there is either it is an invalid array or just one element or whatever. Yes, and the element is of course not there, and we return false. Then we first get a middle index, which is the, you can say, the starting point for our search, which we get as using the integer division. And we have math.floor function also that can be used. Then we print the middle index and the element on the middle index. If this element equals the search element, which is defined here, then we would return true. That is, we have found the element. In case the middle element is greater than the search element in a and remember this is sorted array. So that means suppose you have something like 1, 20, 45, 89, and we need to search for 20 and the middle index is I think on 45. So 45 is greater than 20. So that means we need to go to the left partition. Basically we divide into two partitions. One is the lower plane ranges and the other is the higher ranges. Then again the trick is here in recursion we again call binary search, but there is one change. Array remains the same. The start index, in case this element remains the same, the end index becomes middle index minus 1 because see it is a sorted array, so not applicable in this case. But suppose if I'm want to get 45 or just me, okay, and if I want to get something like 23, then I will have starting index as this one, and then end index might be 40, and then I would continue. Else we need to go to the right partition. Maybe we can also write like air mid index greater or less than search element, then we need to go to the right partition. Suppose we are searching for 90, so the middle index would be might be 40, then it is less than 90, so we need to go to the right partition, and then again we give a recursive call. So this is the pseudo code. Now let us see how we actually write it. Okay, so here I have defined the function in Python code. Again the def stands for the function keyword, and if start index greater than end index, then we print the search element not found and we come out of the program. Then we get the middle index, which is the integer division, and then there are a couple of print statements: start index, end index, middle index, and the middle element, which is at the middle index element. Then if we find the element at this index in the one first go, then we return such element found. And in fact this was iterate when we call if it is greater than or less than search element, so we are giving a recursive call, so it would again come to this one. If at another iteration we get the search element at the middle index, we would return. This way we go through the program and then we call it. So this is one way to call. We pass an array and we get an input. It is an interactive one. We can of course go with the non-interactive, which I will show. 5 9 12 18. So this is, and we would give some element to search, and the other way is we directly pass an array like this way: 5 9 13 43, and then we pass starting index 0 and then 7 and index, and we need to search for 43. Yeah, one thing you need to see, these are sorted. If you do on an unsorted one, you will not get the right result because of course the binary search expects a sorted input. If we need to do some kind of search and unsorted, then of course there are other ways. Okay, so let us run this program. Let us run the complete program. Okay, or maybe I need to comment this one. Okay, here we go. So we need to search something. So randomly I type 23. Okay, so it tried going to left partition, right partition. It did not find. So it says search element not found because of course 23 is not in this list. Now I would again let me clear this up. I will again run. So I will give element 81. Let me try with this. Okay, so see, it starts from this start index. Middle index is 4, element is 25. 25 is less than 81, so it needs to move to the right partition. Then it starts from 5, fifth element, 1 2 3 4 5, from 25, and then it needs to go to 81. Middle element is 56, it is still less, Then it starts at 8 and 9. Middle index is 8. Again, it comes at 9. So element is found. So this is the iterative or the recursive process. And similarly, we can try for other element. Let me try for something that is the on the left side. Let me try for 18 and see. So it first search 25 is more, so it has to go to the left partition. Then it checks 9, it gets 9, no, it is not okay. It checks for 12 at the middle index 2, that is this one. It is also less, so then it needs to go to the right partition, okay. Then it starts at 3, ends at 3, so basically middle index is also 3. Element is found, it comes out. There is another way where we directly pass. So here, this is the array and we need to search for 43. Accidentally 43 is around the middle. Okay, let me try with 13. Let me give a try. Clear this one, run this one. Just a moment. Let me comment all of this. Now let's execute. Seems to be some problem. Okay, it was already running. So see, it started at 0 and middle index 3. 43 is more than 13, so it moves to the left partition. Then it starts at 0 and at 2, first element 9. Again, 9 is less than 13, so it moves to the right partition. And then it comes at start index 2 and index 2, and then the middle element 13. And here the element is found. So you can also try other things. Let me show you an example where it is not sorted, just if you were curious. So let me do this. 60s, wait, 30, just random numbers. So this is not sorted, and if I try to search for 90, let us see what result it shows. Okay, so this list had 90, but you can see what happened. It expected a sorted output, so it calculated based on the different inputs, and finally it came to 78. It did not even touch 90 because again it needs expect a sorted input. So you can go through the calculation, how it calculated and why it skipped, but the core idea is if it is unsorted and you try to do it with a unsorted array, it will not work based on the way we code for binary search. Of course, there would be other ways. Maybe you can go for some kind of other searching, or maybe sort the array first using quick sort, insertion, selection sort, and then go for binary search. That could be another way. So this is what I wanted to talk about. I hope you would find this way of coding for binary search useful. Have a nice day.